Hi, this is Mrs. LaBarbera. This is AP Physics Mechanics C. Today we're going to talk about a question of collision. Here is an example from past exam. A 2 kilogram block and an 8 kilogram block are both attached to an ideal spring for which K equals to 200 newtons per meter. And both are initially at rest on a horizontal frictionless surface as shown in the diagram. In an initial experiment, a 0.1 kilogram ball of clay is thrown at a 2 kilogram block. The clay is moving horizontally with speed v when it hits and sticks to the block. The 8 kilogram block is held still by a removable stop. As a result, the spring compresses a maximum distance of 0.4 meters. Part A, calculate energy stored in the spring at maximum compression. So we know the compression, 0.4, we also know spring constant. From those two quantities, we can figure out the energy stored in the spring, which is this equation. Substitute the numbers in, you should have 16 joules. Part B, calculate the speed of the clay ball and the 2 kilogram block immediately after the clay sticks to the block before the spring compresses significantly. So here is a ball of clay is thrown to the block. The two stick together, then the two are going to move, compress the spring. So during this motion, the 2 kilogram block and the ball is moving to the spring is compressed, energy is conserved, because the only force during this process is the force of the spring. And we know the force of the spring is a conservative force. So the energy before equals the energy after. Energy before is just kinetic energy of the ball plus the 2 kilogram block, the two moving together. Energy after is the energy of the spring. So the ball and the 2 kilogram block is 1/2 mv squared. This m you have to add the two together, times v squared equals to 16 joules. 16 joules we got from part A, so we can solve for v. Part C, calculate the initial speed of the clay. So here is the initial speed. So this collide with 2 kilogram block, and we know the two move together with 3.9 meters per second. So what is the initial speed of the ball? This is a conservation momentum problem. P before equals to P after. Before is the ball of the clay, the momentum of the clay. After is momentum of the clay plus the 2 kilogram block. Substitute all the numbers in. Remember, after is the two add together. We know the speed is 3.9 from part B, so we can solve for V, 81.9 meters per second. Now, in a second experiment, an identical ball of clay is thrown at another identical 2 kilogram block, but this time the stop is removed so that this 8 kilogram block is free to move. The question is, state whether the maximum compression of the spring will be greater than, equal to, or less than 0.4 meters. Explain briefly. Because 8 kilogram block is able to move, and it will move. Why will it move? When the ball is sticking to the 2 kilograms, moving to the right, this is going to compress the spring, exert a force on the spring. In turn, the force from the spring will push the 8 kilogram block to the right. So 8 kilogram block is going to move. As a result, the spring will compress less than 0.4 meters. This is again because 8 kilogram block will move due to the force from the spring. The sum of the energy in the 2 kilogram plus the ball will change into the kinetic energy of the 8 kilogram block. So therefore you have less energy stored in the spring. Part E, state a principle or principles that can be used to calculate the velocity of the 8 kilogram block at the instant the spring regains its original length. Write the appropriate equation to show the numerical substitution, but you don't have to solve for the velocity. So this case, let's see, so the ball and the clay basically is colliding with 8 kilogram block. And this collision is elastic collision because the only thing between them is the spring, and the spring is conservative force, right? It doesn't take energy away. So the collision is elastic. In an elastic collision, both momentum and kinetic energy are conserved. But you'll have to write the equation. Momentum is conserved means P before equals to P after. P before is 2 kilogram plus ball plus times its velocity, which is 3.9 meters per second, equals to momentum after. So again, this is the 2 kilogram plus ball times V1, that's the velocity of the first one, plus 8 kilograms block times V2. So in this equation, you have to solve for V2. The other concept, principle is conservation of energy. So total energy before, for the this is the 2 kilogram and the ball energy, kinetic energy, equals to the kinetic energy after. So the 2 kilogram and the ball plus the plus the 8 kilogram block speed. So now you have two equations and two unknowns. So you have a system of equations to solve for the unknown. Okay, that's it. Thanks for watching. See you next time.